This conference will now be recorded.
Okie dokie, so today's yet another attestation day. I've done a lot on the document. It might be hard to tell, but I wanted to go over some of the things that I've done and request some help in spots. So something I am going to do, because I find I've put these blue requirements or even the musts and the mays throughout the document where they sort of belong. But I realize they don't jump out at anybody. For somebody who wants to look at the document and say, all right, what do I have to do? Then I'm going to add headings before each one of these. So for example, this will be requirements for a conformance statement. And then I'll do that as we go through the document. So they'll be easier to spot. I mean, they're easy to spot with the blue, but it doesn't describe what they're asking us to do. So that's an easy one to do. I focused a lot, my main attention was on the key table, which we've been working on the last, I guess, 2 calls. And there were a lot of suggestions that I've incorporated, and I want to go through that, at least some of the changes, and then request some help. Before we jump into that, let's go to, let's see, page 6 here. All right, so we had suggestions on adding a reference to this cryptographic key length recommendation. Let me see if I click on that. This is a really cool website I had never seen before, and it talks all about the different types of keys, how long you should use them for the originator and the recipient, if it's applicable, and then the different algorithms and what strength is recommended, what hashes are recommended for various years. So it's pretty much all in there that we need. It also refers to other standards, not just NIST, but for example, here's, I guess it's Eurocrypt, right? eCrypt. And there are different standards there, but we're sticking with NIST for our purposes. So we'll stay with NIST. Sorry, guys.
Elaine, are you still on?
I am talking on mute. Didn't you hear all that on mute? Sorry. Okay, so what I'm focusing on here now is what in the table should we, what should we say about that's required for the things, the items in this table? The table containing the seed, the identity, the device's identity key pair, the device's attestation key pair, the CA or the provisioner's CA key pair, and the owner's public key. So what do we want to mandate about all of these things? Well, we certainly want good, strong entropy. We don't want, weak entropy where all the devices, their seeds are predictable, right? That would be horrible. We may have symmetric keys if Intel's proposal goes through. Obviously, we have asymmetric keys. So the question to you all is, is this the correct list of things that we want folks to follow? So the first one is 800-57 for key management. The second, there's links to all of these, by the way. The second one is concerned about random number generation using deterministic random bit generators. The third is talking about entropy. Where do you get entropy to put into your random bit generation? This one is for how do you generate keys given randomness. What do you do for your key generation functions? Your KDF, yes. And then the third is what do we worry about in the future for when quantum computing is around? What do we have to do now to prepare for that? So is there anything else that I forgot that we want to point people to? Or are these too onerous to require people to follow? I need some feedback. Would you want to go through the table first and then we'll decide? Is that helpful?
Elaine, if you already pulled out the major requirements from these documents that you reference?
I have not, well, they all apply, certainly, but I have not gone and said chapter and verse, yea, verily, you must follow this specific thing. I mean, all of these are complete documents in and of themselves, right? You think that's too broad?
Okay, but we don't have any notion of whether how old the documents are, whether they're still relevant, how well written they were, and what actionable information there is in them. So that study's got to be done.
Okay. So, yeah, the question is who would like to go through those? Let me show you one. Let's see, we'll go through this one to see how much it is a concern. So, I'm going to get to the right place. So, looking at deterministic random bit generators, if we go through there, it's pretty thorough as far as, hang on, it even covers the hashes that you use in hashing. Trying to get to a good place here. Sorry for scrolling so fast. We got all the terms. We don't need to go through terms. Sorry, there's a lot of front matter here. All right, so this is a good starting place. So this this is very much a tutorial. This part of the document is a tutorial on all of the components that go into the deterministic random bit generator. And it distinguishes between the entropy source, right, and what finally comes out as your pseudo-random output. You know, a lot of people confuse that, right? That they think, oh, well,
Okay.
I just got a random number.
So as far as random numbers go, I mean, that's a whole area of study. Many of us are probably familiar with exploits based on weak random number,
Yep.
weak sources of entropy. Yeah, that's certainly something that should be followed.
Yeah. All right. Go back here. That was this one. Let's go take a peek at the key management one then. And then I've taken the latest one of each. That's what the links refer to. You know, we never have talked about how we're going to freeze this document and make future versions and so forth, how we're going to update it. So it's a snapshot right now, but I don't know what we're going to do in the future. All right, so all of these, hang on, let me get through this. So this is key management. There's a thing that I wanted to go through here where I'm going to need some help. So one of the things that this covers, hang on just a second. No. Yes. Okay. So I don't know if you remember the last time we went through the table. Let me go to the table for a second. I had a column which was for key length and algorithm and crypto period. And the suggestion was excellent. The suggestion was, well, just refer to a good source where people can look it up themselves. And we don't specify it. We just say use what's recommended. So I did that. I took the columns out, and then I realized that we don't even describe what the keys are and what they're used for. And I would love someone to help me here to go through this column, comparing it to this NIST document of here are the types of keys, like private signature key. Let me pick one, for example. So the identity key, we've got a private and a public one. I picked from this list from NIST that it was a private authentication key. So if we go look at NIST's private authentication key here, this says a private authentication key is the private key of an asymmetric key pair that is used with a public key algorithm to provide assurance of the identity of an originating entity. But you see, it keeps going, and it says when establishing an authenticated communication session. So in our case, back to this table, so this is an identity key pair, right? It's saying this is the identity of this device, but we're not necessarily using this to establish a communication session, right? It's to, so how do we advise people on what kind of key we have based on what NIST defines them as? There's a whole list of them. Look, there's all these types of keys. There are 19 different kinds of keys, and it would seem like it would be helpful to folks to define what they are, because the next thing is to go through crypto period, right? And when you get to, let me go back up here, which is also in this document. I can't see what I'm typing. It helps if I spell it right. So if we go to crypto periods, then the type of key and the usage of that key affects what the proper crypto period decision is, right? So it's important to get this column right in the table, the key type and the key usage, because that's going to determine other things. So do I have a volunteer to go check this work that I did to make sure that these are the right types of keys and usage? I also picked, I went through the X509 key usage fields. There's key usage and extended key usage. Is there anybody on the call who's knows X509 certificates who can help check this second piece, which is in a certificate, you should put the usage of this key. What's it for? Is it for signing things? Is it for encrypting other keys? What's it going to be used for? And limited to, because you don't want to use a key for two different purposes, right? So you have to pick what it's used for and then say so in the certificate. So I would love some help with this. I've gone through the first pass and tried to do it with what I know, but is there anybody who can help me with this? There's two pieces I need help with. One is what is the key type, and the other one is what to put in the X509 certificate as its usage.
I'm not the right person, but I'd like to have our Titan folks who work on this attestation problem review the document.
Okay. That would, maybe they can provide some help here. And even key usage restrictions in the certificates, those have been kind of loosey-goosey in the past. So, but enforcement of that is coming, right? So we need to keep that in mind and make sure that we at least identify what the usage is to put in the certificate. It might be ignored for now, but at least we've identified it so we can put it in the cert.
Is there a link to this document shared somewhere?
Yeah, it's in the wiki for the, I can send it to you right now in the chat room. Let's see. I think that should work. It's in our project wiki, in case you lose this document. I mean, this link. All right, so Ben, you'll ask your Titan folks to check it out for me, please. Yeah, I know we have other folks.
Yeah, and it'd be nice to get Cerebus and
Yeah.
anyone else who's already has some sort of implementation.
Brian, are you is there somebody in Microsoft who's a certificate guru and key usage guru?
Yeah, we can take a look at it for you.
Please, okay, that would be helpful.
All right.
It's a pretty limited request. It's, look at this column and tell me if that's the right, if I've made the right choices. And the choices are coming from these documents here, right?
Yep.
Okay, thanks.
Elaine, could you go back to that web page that you had gone to earlier on?
The one that has the key length and all that? This one?
Yeah. And so scroll down to there's a table like for the NIST. There's
I'm on the NIST one.
Yeah, keep going. I thought there was a table below. Yeah, so one thing like here, so one thing we've done in some of our documents is like we say something like, such and such a key must have a security strength of like 128 bits, minimum, which you can see in the second row, that's supposedly covers you to 2030. So in other words, 112 is not sufficient, is what in our documents. And so one approach to specifying what the strength is to pick one of those columns. It could be 192, it could be 128, and just say that's the minimum. And so, obviously 80 or 112, maybe is not acceptable. So that's one approach you could take to specifying a minimum strength.
Yeah, I thought about that because I had that in my notes to go and, consider putting minimum strength in there. But then it depends on the algorithm, right? And if we're not going to
That's right.
specify
Well,
algorithm,
I mean, but this supports different algorithms. If you say
right,
128, then whether it's AES or RSA or elliptic curve or hash, I mean, you've identified, the corresponding algorithm. I don't know if there's other algorithms not covered here. I mean, I'm not sure. Like in the other for other geographies or something, if it's China or something else, I'm not sure.
right. But then how do you know whether a company's target is, beyond 2030? Like for another company, it might not be that long.
Yeah. Yeah, I guess it's a question of whether we want to just say, well, it's up to you, or specify a minimum strength. I don't know what the.
Oh, so
I
Stuart,
guess.
here's an idea. So when back up way up early here where we first started out the call, it says you must provide a statement of conformance describing any choices allowed by this document. Maybe that's how we deal with this, where we say, tell us your choices. What have you chosen? So we could put that in here. But what do we say? To provide something, provide a statement of minimum key strength periods. And what else? What else do we need to know? Well, they don't even have crypto periods. Oh yeah, they do have crypto period. There's crypto period in here. Strength. Here, is that enough? We tell us what your crypto periods and strength. I'll just put these values, right? Well, then we could at least find out what they chose. Would that work, Stuart?
Yeah.
Or you
I
want to
think
be
so.
strong?
Yeah. I mean, if we don't want to dictate a specific strength, then yeah, a statement of what the strength is, I think would be good, or certainly necessary.
Yeah, and they must do that. It's a requirement that they do this. Okay. I like that because it's really hard for us to dictate anything, but this way we find out regardless.
Mm-hmm.
All right. Other suggestions? All right, then let's move on. All right, let's see. Another thing I deleted was down here. I think we've, you know, we came up with all of, as we were brainstorming on the scope of the documents and what we were going to cover, these things were within our scope, right? And we were going to discuss them in the spec. I think we're covered here. I think we've adequately covered this topic for 8 and 9. So I'm just deleting this out of our outline. We don't really have, I don't know if the threat model talks about the protection from attack on the random number generation. Anybody remember? Brian, do you remember?
Yeah, I don't think it did. The threat model, I don't think it went into that level of detail. Yeah, so we hadn't put it in there like random number generator attacks.
Yeah, maybe we should, huh?
Yeah, I'm not sure where it would fit in that document. The document was pretty high level, but take an action to go look at it for sure. I think it's definitely worth mentioning. You know, I think Ben mentioned earlier the known attacks on weak entropy.
Yeah. All right. So, I mean, even if we don't put it in there, we've at least covered it in our requirements, right? At least to say they must comply with these recommendations. All right. So Brian, you're gonna go dig in that one too?
Yeah, I'll take a look at that.
Okay, thank you. All righty, let's keep going here.
I don't expect we talk about compliance testing anywhere in here. That's a big project, something separate, but I would think it should at least be a to-do.
Yeah, that's a nasty one, isn't it?
Yeah.
That's, you know, that's a whole nother another effort.
It's a whole nother effort, but it should be mentioned as something that should be done. Laying out requirements and not telling people how you're going to measure them.
Yes. What do we have in here? That's a good question. So let me go back. Do we have a, oh, phooey, we don't have a table of contents. Oh, right, because of this. Sometimes I wish I could dispense with this and just use a real formatting system that I can do more with the document, like table of contents. All right, let me
There's
take
a table of contents primitive.
There is?
Yeah.
Oh,
You can insert a table of contents.
oh, I'm going to do that.
Do it after your introductory paragraph at least, or 2.
I mean, after, yeah, before, well, yeah, I think before this introduction. Okay, I will learn how to do that in Google Docs. All right, on to the last thing. I think I have this diagram. Okay, so we had originally, I'm sorry, I'm just scrolling here. It makes me dizzy when other people do this. So this was the original document that we had, and I never could get the source for it. So I just redrew it, but then I took the opportunity to change it a bit. So I wanted us to go through this again. Oops, how did I end up here? My goodness. I don't know what I do this all the time. I don't know what I'm doing.
I just inserted a table of contents. So you probably got jumped.
Oh, that's what it was. Thank you very much. That's what it was. Okay, so the original, let me go back to the original diagram for a minute. So the original diagram was way back when we talked about manufacturing instead of provisioning. And it specified ASICs instead of just devices, right? Which we want to deal with devices, not necessarily just ASICs. And it didn't show that this injection type of provisioning was sort of optional and less than desirable. So I changed the diagram here to also, I needed to make this correspond to some of the text down below so that we could match up the diagram to the description of the diagram. So what I did was I added this arrow, I changed this arrow so that it shows that these devices are incapable of doing their own self-generation of the random number. And if it either gets its randomness from here injected, or it self-generates its own unique device secret. So that's those two options there. These arrows are just flow arrows. It's not data arrows. It's just how does it flow through the process. And I think I need to change the color or something with these arrows, because to me, I'm getting them confused between data and process flow. Okay, so then once we have this unique device secret, then we can generate a public-private key pair. We're missing another step in here, which this is the identity key pair, which then goes to the provisioning CA, who issues a certificate for that identity key pair. And then that goes back into the device, and then the device ends up getting owned, and it gets an owner's certificate put into the device at the end. I'm missing the step that talks about the attestation key pair, which needs to be in here, because there's another step that's not shown. So level of detail wise, this is a lot less detailed than all of this here, but are you all okay with that? I could put the details, but I'd rather put it in the text than in the diagram. You know, like sending the hash of the ASIC identity. Well, it may not be just a hash, right? There may be more that comes across like device identity. And so I thought this was too specific for our purposes. You okay with that? Let me go back to
Yeah, I think it makes sense to move the text out of the diagram like you're doing.
Okay. All right, and then I'll add, it's funny when you go through these things and talk about it in front of someone else, you see your own mistakes, right? So I have to add that attestation key pair in there. All right, I think I have only one other thing for today. Oh, this is really a nit, but remember I said that I really want to point out the requirements. Can I find it? There it is. All right, so in this section here, we're talking about let me go back up, the provisioning step, where we're creating the device's ID and getting its certificate and so forth for the identification. There are a whole bunch of requirements that we now have for that step. Let's see if I can shrink this down. So we have quite a number of requirements all about these provisioning operations. In addition to the one about quantum resistant algorithms, I added that one as well. And I added FIPS 140-3 because we can't really say yet which one they're going to have to comply with, because it depends on the timing of the device and when it's out, right? Because it's got to be done by 2021, but if you have a device already in the process for FIPS 140-2, then it will be after it can fall after the transition time. So I just added
Isn't one of the FIPS requirements, I forget which standard, have a requirement for a non-open source implementation?
Ooh,
I
I
seem to
haven't
remember
heard
that.
I haven't heard that at all.
There's some.
Ooh,
Let's see. It's a hazy memory. I'll see if I can track it down.
wow. That would be a big step if it did. That's a huge step. Hmm. All right, so what I'm, oh, here it is. So I also added the KDF. Where do you go learn how to do KDFs? Let me see if I click on this guy. So NIST even tells you how to do that. I'm wondering if we're sticking with NIST is going to work for us, because so many of us are in these, global companies that have to worry about other countries too. But this tells you what kind of hashes to use, if you're going to use a MAC, HMAC. There's choosing your salt value, truncating hashes. There's all the details that you would want to know about KDFs based on NIST's recommendations. So I added that, the KDF. And the thing I'm going to do is for all of these blue requirements, I'm going to put them in their own section. So this is going to be requirements for provisioning. And that's all I have for today. But I do appreciate some help on that key table. I think that key table is going to be very helpful when we get down to implementation. And I think that will help if we can nail this column down, make sure that's right. So any other comments, suggestions, volunteers? All right, so for action items then, other than I'm continually editing the document, I'm going to accept the changes that we reviewed so that next time we'll know what I've changed again. Thank you, Ben, for the table of contents. Let's see, and Ben and Brian are going to go to their respective organizations to get some feedback on this column here. Brian, you're going to add something on the threat of bad random numbers.
Yeah.
Oh, and Ben, you're going to find out about this FIPS requirement for a non-opaque implementation.
Yeah, I'm gonna see if my recollection is correct on that and what it applied to.
Okay. All right. Anything else then? No?
No.
All right. Thanks everybody for the feedback and the
Thanks.
volunteer. Yeah, you're welcome. So Mike, I guess you can turn us off. Oh, did he go away? Well, I can't turn us off, but I guess you all can hang up. Thanks everybody.
Have a good week.
You too.
Bye.
Bye.
Bye.